unlike Dragonfly, still asking the same question, distinguishable permutations, count the number of different words, they don't have to be in the dictionary, that can be formed. So for Butterfly, however, what we start to notice is that there are two T's. So what would start to happen is we could write this as butterfly. However, if I were to rearrange the letters, technically this has rearranged the letters. However, did it create something new or individual or special, I guess? No, it's still the exact same word actually. And so anytime that you were to do this, so let's say I have T-B-U-E-R-F-L-Y, and this time T is at the end. And actually, I'm going to use this first T in a different color. So again, in this case, we've rearranged the letters technically, but we haven't created something new. It's read the exact same way, and it's still just as much not in the dictionary in this case. But we aren't worried about the dictionary. And so what we have to do in this case is we have to account for those two T's, because really, what happens, since this is still 1, 2, 3, 4, 5, 6, 7, 8, 9 different letters, and I'm choosing them 9 times, so this is really 9 factorial. However, every single option I have, the T's could switch and it would be the exact same one. And so really what we're going to do is we have to take half of them. Okay, and so it's going to be 9 factorial divided by, interestingly enough, 2 factorial. Now, 2 factorial again is just 2 times 1, and so that wouldn't change too much up. And so you can enter this into your calculator, and 9 factorial divided by 2 factorial is going to be 181,440 distinguishable permutations. Again, distinguishable. The only way that these two were distinguishable is because I changed the colors. If they were the same color, then it wouldn't matter. They were all the same color, it would not have affected and made it distinguishable. All right, let's take a look at this last one, even more repeated letters. Okay, so what we have here is B, B, and B, and we have E, E, and E. I still have 9 different, 9 letters, not different letters, I have 9 letters in all. However, each time, let's think about this, just for B, we're going to use quite a few different colors. So this is Bumblebee. Okay, this is one way, it's the blue, yellow, green. Just saving myself some time instead of switching between the colors. And I need one more. So, just like the ABC at the beginning of the last video, I can choose blue first again, and then green, and then yellow. Or I could choose yellow first, and then green, and then blue. Or yellow, blue, green. Or I can choose green first, and green, yellow, blue. Or green, blue, yellow. All of these are only distinguishable because I wrote them in different colors. If they weren't in different colors, again, if they were all red, they would all read Bumblebee the exact same. However, each time I switched the bees around. And so what we've realized is there's not only just one Bumblebee, there are 6 different possibilities just by switching the bees. And so what we need to do is we need to divide this by 6, just like in the last one where we had 2 different possibilities with the T's, we divide by 2. However, a better way to write this or think about it is actually we want to divide by 3 factorial. And what is 3 factorial? It's 6. And so essentially, in order to account for just the B's, I'm going to divide by 3 factorial. Well, what do you think I should do for the E's? How many E's were there? There were 3 E's. So I should probably also divide by 3 factorial in order to account for the B's. Sorry, the E's and the B's. So now when I take 9 factorial divided by, and again, if you're entering this in your calculator, make sure this is in parentheses, 3 factorial times 3 factorial, there are only 10,080 different possible distinguishable permutations in this case. Again, that's because the B's can go and switch around 6 times. The E's can do the same thing 6 times. 3 factorial is 6, 3 factorial is 6. And so the reason that I'm having you use the factorial rather than plugging in 6 right here is because what if I had 5 of the same thing? Okay, so let's say I had 5 E's in the same word. You don't want to count out and figure out how many there are actually going to be. You just want to say, okay, in order to account for this, I need to take 5 divided by 5 factorial. In this case, we took divide by 3 factorial. If you have any questions, please don't hesitate to email me. The homework is going to be page 708, 1 through 22.